Okay. Hope I'm audible, right? Can you just once again confirm me in the chat, or can you just give me a thumbs up? Okay, fine. Thanks. Okay, so what we will do is that, welcome to the webinar. So in this particular webinar, I'm actually going to cover data science part more rather than the agile part. Okay, agile part, yes, because in the past we have seen a lot of webinars and my YouTube channel, right? So in this particular webinar, we will see some of the basic concepts of data science, and then probably slowly as part of the webinar I will be trying to shift the gear. Okay, like I'm going to begin with the basic concepts. From there I will slowly try to tell you the machine learning, deep learning, basic concepts of a generative AI, and from a pragmatic approach, how we can suffuse agile basically into the landscape of a data science. That will be the high level view. So what you can do is that to actually begin from the basics, right? Why do you think that a data science is important? So please go ahead and then put your thoughts in the chat, like whatever thoughts come to your mind, no? Because we keep hearing lot of artificial intelligence, deep learning, machine learning, generative AI, LLM, large language models, right? So why do you think the field of data science is emerging, evolving, and it is becoming more important nowadays? So please go ahead and then put your thoughts. In the meantime, I'm just going to take some of my own articles from the LinkedIn, and then now I'll just keep it ready for you people to, like, we'll just get into the crux of the webinar. Hope you are able to see an article in the front of you, right? Something like the complete life cycle of a data science project. So go ahead and then put your thoughts. Okay, Anand says due to significance of data-driven decisions. Okay, that's a good point. Getting meaningful insights for the business. Okay, market is driving towards more of a data. Okay, so if you want to do just to make it very simple, if you want to do any kind of a futuristic projection, right, you actually need to know what is the historical data that we have in place, and the constraints around the data, the context around the data, and then probably you try to build a model which has the capability to predict the future. That's why we are actually getting into the world of data science, right? So okay, why are we trying to predict the future? So what could be the business reason that, like, companies like FedEx, or companies like any kind of a logistics company, or even companies who are actually having some kind of a business which involves primarily a data analytics kind of an approach, why do they want to predict the future? What will happen if if you don't predict the future? Okay, decision making. Okay. Better decision making, avoiding the failure, or rather, in sometimes you cannot avoid the failure. Sometimes definitely you can try to mitigate the damage created by it. Yes. Okay, got it. So, for example, right, let us take some simple examples. Now, a company has the historical data for the Q1, Q2, Q3, let's say, for example, and they wanted to predict the revenue margin, they wanted to predict the EBITDA, and they wanted to predict the CAGR, compounded annual growth rate, and they wanted to predict some kind of a financial terminologies for the next quarter. So do you think that if you have Q1, Q2, Q3 data in a very structured and organized manner, Q4 data can be predicted to a considerable extent? Do you think it is possible or not? Yes, we can. Okay. Of course, the degree of variability will be there. See, if, first of all, we are not looking out for a perfection over here. We are looking out for a refinement in our thought process, of course. Okay, and then you may need to build the model, and then you need to do something called as a hyperparameter tuning, hyperparameter optimization, all those things which we will cover at least on a high level. So, what I suggest you people is go to this particular link, okay, and then you can open this particular link in your own browser parallelly instead of just looking into the this particular Zoom video, okay. So please go to this link. Hope you are able to get the chat in the URL, means the URL in the chat box. Please go to that link and then open that particular article in the browser. Let us try to go through that article on a high level, okay, and then I will slowly shift the gear. Okay, now, if I go to this particular article, right, this is the data science and life cycle, any project you take, okay. First of all, we need to define and understand the problem. We need to collect the data, some kind of a data, okay. Depending on the context, the data will change. For example, if I want to predict the revenue margin, or if I want to predict the probably the cyclone impact, like in a particular region, like in the country Orissa, okay, in the country India, for a region Orissa, every September to December, probably what will be the probability of recurrence of cyclone and what will be the devastating impact created by the cyclone, let's say. So first of all, I need to know the historical trend, right? So I need to collect the data. Now you guys tell me, do you think can we take the data as it is and then try to build a model? Just think practically, right? Do you think, let's say I have collected the data, can I take the data and then try to build a model? Yes or no? Can you just put it in the chat? Let's say I have let's say I have collected the data. Do you think just by collecting the data can I build a robust model? No, right? Okay, so Sriram uses the word massage. Probably I will give a better word called a manicure. We may have to manicure the data, means you may need to tweak the data, customize the data, right? All those things we okay, see, okay, now understand the concept. I have collected the data, but why I cannot build a model? Because I need to do cleaning of the data. What do you mean by cleaning? The data may have a null value. The data may still have some kind of a noise. Okay, so what do you mean by noise? Anything which is not leading you towards the goal is a noise, right? Some unwanted data which may give a biased approach in the model. And that particular data may also have a missing data. Like for example, you may get some data for a few weeks and then you may have some missing data. And probably we actually tend to call this as a uh, we actually tend to call this as a imbalanced data. Okay, so when you study data science, there is a difference between a balanced data versus an imbalanced data. And also you may need to handle something called as a categorical data values, something you may need to do normalization on the data, because your raw data cannot be deemed fit for me to build a supervised learning or an unsupervised learning or a reinforcement learning, depending upon the algorithm classification, be it a deep learning algorithm or be it a machine learning algorithm. Okay, this is the funda. Now, somewhere you know the basics, right? You have your artificial intelligence. Inside that, you have a subset called a machine learning. Deep learning is see, if you go by the purist approach, book says deep learning is a subset of the machine learning. From a pragmatic approach, deep learning is an advanced aspect of a machine learning where you have your concept of a neural networks. Like the human mind, human brain conceives and tries to learn, we are actually having a subset of the machine learning called a deep learning, wherein you try to simulate the human way of learning things, right? Pattern recognition, image recognition, all those aspects, right? Then you get into generative AI and all. This is the concept, okay? I'm sure that you know the basics. Okay, now coming back to this particular article, right? Here, what I have written, You need to understand the problem, you need to collect the data, and you need to do the data cleansing. Okay. So when you go through this article, I have explained here, like handle imbalanced data, try to remove the, because I don't want to take someone's material from the internet and then explain you folks the concepts. Okay. I have not even prepared a PPT for the webinar. Just I want to make it a live thing from my own article. So these are all the concepts which you need to keep in mind. Now, then what we do, we actually have something called as a feature selection, which we call feature engineering. Okay. There you have something called as a exploratory data analysis. So these concepts you need to take one by one later. Okay. Because in feature engineering, we have different ways of, you have, for example, based on the data set, you may need to classify it, and you have a concept called the curse of dimensionality reduction. You may need to take the right kind of a data set, because too much of data will also try to introduce a biasing pattern in the model. So, but too little of a data will not enable you to extrapolate it, so you may need to take a balanced approach there. So we have the concept called the curse of dimensionality, and the way to reduce it is called a dimensionality reduction. And you also have a concept called a PCA, principal component analysis. So these are all some of the core concepts which you need to know in the world of a data science, typically in the world of a feature engineering. And then you build a model, and then you try to deploy the model, and you continuously tune the model, like and once you feel comfortable with it, probably you will try to use that model to extrapolate for your futuristic needs. Okay, this is the funda. Do you guys have any question till now? Are you okay with the overall picture? Now, then we will get into the nitty gritties. Are you okay with the overall picture, right? What are we trying to do, and most importantly, why are we trying to do? Okay, good. Okay, now actually let us take a um, uh, 1 second, wait. I have just prepared some parallel notes and then kept it ready for you people. Let's do one thing. I'm just taking this particular notepad. Okay, I'm just going to a place called the webinar notes, a simple notepad wherein I'm just going to type something for you people. Okay, observe it with some attention here. Okay, now what are all the building blocks which you need to know? Let's say that you wanted to do a simple project in a data science. You can take the same example. I want to like build a data science model or a AI model to predict the quarterly business review, QBR, for one of my client for the next quarter. This is the problem statement what you have, right? So from where will you begin with this particular understanding? With the high level what you saw in the article, from where will you begin the journey now? Can you please go ahead and then put it in the chat? Let's say let's say this is the problem statement that we have, right? To build an AI model to predict the QBR, quarterly business review numbers for the next quarter, based on the previous data what we have. So probably from where will you do? Okay, gather data for past 3 years of a QBR data collection. Good. So you are actually beginning with defining the business problem. You have defined the problem statement. See, in an interview, right? Okay, don't think that I'm jumping the gun. Before I forget, I just want to pour out my thoughts. In an interview, the storytelling aspect is very, very important, typically from a data science perspective. Generally, people think that if I know this algorithm, if I know that algorithm, that is fine. Algorithms come at a later point in time while you are trying to build the model. But the point is, interviewer will be looking into what is the problem statement, what is the approach you have taken, and most importantly, why you have taken that particular approach, and what is the solution, and how does your solution is predictable, repeatable, scalable, sustainable. So just keep these 4 points in the mind. Any solution that you are trying to build a model, right, for your AI model, it should be predictable, it should be repeatable, it should be recurrence, predictable, repeatable. Third is a scalability aspect. This model works for this particular data set. If the data set grows, does the same model will be replicatable. So third is a scalable. Fourth is a sustainable, right? That solution should not be a one-time solution. So one of the important skills or capabilities that you folks needed in a data science interview is this storytelling ability. That narrative should come out when you have the conversation. Then of course, when the interviewer asks you, hey, okay, so how did you build the model, what is the algorithm you have used, whether you used k-wire nearest neighbor algorithm or db scan or clustering xgboost, you have a lot of algorithms. Okay, those things we'll see later, but that narrative should come. Okay, now with that point in, with that perspective in the mind, now we will continue the show. So don't mind on the spelling mistakes and all. It is understood. Okay. Now, first thing, what you need to know. Okay. See, now here I'm going to cover the entire landscape, and then we will get into the nitty-gritties. First thing, what you need to do, you need to be good in one of the programming language, right? It could be Python, it could be R. Even you can use Java, but generally Java doesn't have importable libraries, utilities, and packages. So generally, I prefer to use Python, but because Python gives you Panda, NumPy libraries, which you can easily reuse it. And the second thing is you need to be good in a machine learning or your deep learning algorithms. Okay. Okay. Then the third thing is you need to be at least good in one of using the IDE, right? Your integrated development environment. Because if your IDE, if you don't know how to use the IDE, then things will be difficult for you. So for Python, you can go for a PyCharm. You have an IDE called a PyCharm. You have something called the Jupyter Notes, Jupyter Notebook or a Jupyter Notes. Okay. And you also have something called a VSS Studio Visual. Okay. But I generally try to use only PyCharm. But still, to give you examples, I'm just giving you this. So one of the IDE, you need to be good. Then comes a concept called a web scraping. Okay. This is something I will tell you later. First, I'm just putting the high level. Then you need to be good in the mathematics. Then definitely you need to have something in like a data analysis related capabilities, followed by data visualization. So don't mind on the spellings. Okay, like as I already told, followed by the deployment. So just to cut a long story short, if you wanted to become a data scientist, a successful data scientist, you need to be good in all these areas. Because data science is a multifaceted cube. It is not a single capability. Like you have 7 colors of the rainbow, you have these 7 or 8 aspects. And in each of the aspects, you can select one tool because you cannot master all the tools in the market. Okay. I'm just trying to teach you people how to learn a subject very fast. From the IDE, you can select PyCharm. From the language, you can select Python. Then from mathematics, you need to be good in the linear algebra, differential calculus, those kind of concepts. Visualization, you can go for a Power BI or a Tableau report, which I'm going to cover on a high level. But these are all the things which you need to be good. If anything in this is missing in terms of the capability, probably becoming an expert in a data science could be a challenge. You can know the subject, but it will take some years of practice to master it. Okay. Now I'll just, okay. Is the flow of the webinar is okay for you people? Can we just continue with the momentum? Are you okay, right? In terms of slowly getting it. Can you give me a thumbs up if you are okay with the flow of the webinar? I'll just continue in the same momentum. Okay, cool. All right. Okay, now we understood what we don't know. See, the known unknowns, right? Now at least you know, okay, these are all the things which you need to learn. Now you can decide from where to begin. See, different people have different ways of learning. Okay, for example, let's say Okay, I'll just pick some names here just to be interactive. Let's say Leela wanted to master data science. Leela has her own way of learning, which may not resonate with my way of learning or a Shailesh way of learning, right? So one way of learning is you can take one by one. You spend some 2 to 3 months only on a Python, and then try to integrate. You use the PyCharm IDE, try to write some Python scripts, be familiar with lot of libraries like pandas, numpy, all those things, and then you can master Python on a high level, and then you can spend some 3 to 4 months only on the mathematics, then probably 3 months on the Tableau, because Tableau gives much more robust and powerful dashboards compared to Power BI from my experience. Of course, data visualization, Tableau comes with a higher cost aspect compared to the Power BI, but you need to take a trade-off call, basically depending on the client license. So like that, you can take one by one and then you can learn, which is one way of learning. The other way of learning is you take a use case like you have here, right? See, for example, when I share this link, you folks will come to know these are all the data science related articles what I have written for in the last 6 months. Somewhere around 31 articles I have written. So what you can do is here you see you have lot of use cases given. Real-time case study in data science, fraud detection and prevention, blah blah blah, something like that. AI model for predicting quarterly revenue margin, real-time use case in BFSI, healthcare, and automobile. So what you can do is you can take a use case and then try to solve that use case through the funnel of the data science life cycle. So how you learn, it actually depends on you, whatever you feel as comfortable. Okay. So, okay. Now let's continue with the momentum now. Okay. Now let's go one by one. Okay, so what we will do, so programming language, I have already told you people, okay, you need to start with the Python, start exploring the power of a Python, start looking into the importable packages, utilities. Python gives lot of libraries which you can reuse, which is point number one. Now let us get into the machine learning. Okay, so for machine learning, what are all the things which you need to know? Probably it will be good if you know 6 kinds of different types of uh, algorithms or different ways in which you can apply machine learning concepts over there. Okay, I'll just type one by one. Classification, regression, this could be one thing. Then the third could be reinforcement learning. Sorry. Fourth could be deep learning. Then probably you may need to know some concepts on the dimensionality reduction. Then you have something called the clustering. DB scan also you can include if you want. So these are all some of the high level things which you probably most probably it will be, these are the concepts which you may need to know. See, for example, at least you need to know the high level, then we will get into which particular algorithm has which particular pros and cons. See, it's like Agile, right? You don't have a single framework which which will solve all the problem on the planet Earth. Correct? We will take some concepts from Kanban, some concepts from Scrum, some concepts from Spotify, some concepts from Safe. Then you create your own customized Agile framework, which will exactly solve the fit for purpose. Along the similar line of thought, no single algorithm is going to solve all the business problems. But you need to know the first step is what are the different types of algorithm. Second step is what are the pros and cons of each and every algorithm. Then the third learning is given a scenario or a use case, can I go for clustering versus some other techniques? So you may need to take a trade-off call. Okay, so I think that's the way to learn. Maybe some other mentor or a coach may give a different perspective altogether. Okay, okay. So these are the concepts which you need to know. Then, okay, now you people tell me from where will you get the data? From where will you get the data to build your initial model? Please go ahead and then share your thoughts in the chat. We are saying that we need to have some data to build the model, right? So from where will you get the data? Like primarily you may need to get the data, right? So from where will you get it? Is there any way to get the data? Unfortunately, video is not working. That's okay anyway. Okay, so data collection is the process to is the one of the steps in the data life cycle wherein yes, you are going to collect the data, but who will give the data to you? Make some guess. See, what is the order in which we have to start? Order is this one. 1, 2, 3, 4, 5, 6 is written here, no? Defining and understanding the problem. Okay, if you are asking about life cycle, this is the order. But if you are asking about me, the learning, it all depends on you. But it is always better to begin with Python. You begin with, you finish off Python, you finish off Tableau, then you come to the algorithms, and then we will think about deploying so that you are covering, by and large. Internal and external sources. That's a good answer, because in some companies, some of the data you can get it internal itself. Organizational document, any kind of a DB sources, APIs, external system APIs. Okay, now let me. Okay, now what we will do is data can come from n number of places, right? So in the place of web scraping, you have this concept, correct? In the place of web scraping, you are going to collect the data. Okay, now what are all the ways to do it? There is something called a beautiful soup, which is a library, and there is something called a scrappy tool, and you also have something called a URL lib. These are all some of the libraries or utilities or tools which are already available, which will help you to collect the data. And as some of you people have rightly mentioned, you may need to look into some kind of a third party, because sometimes not all the data will be internal to the organization. You may need to have a some kind of a external vendor or a supplier integration or a third party API. You may need to consume the API, or you may need to use some kind of a JSON file, and then you try to consume the API. And once you build the REST API service from the front end, it can be readily consumed. That is the concept or the process. Okay. So probably we'll come back to this later, but this is the high level flow. Now let's go to the mathematics part. In the mathematics, you need to be good in the statistics. You need to be good in the linear algebra, at least to some extent. Then you may need to be good in the differential calculus based on the need. Okay. Because anything, if you want to measure as a time series, anything you wanted to measure, then you may need to know dy by dx, the rate of change of that thing with respect to x or the time factor. So you may need to know the differential calculus concepts. So I think these are all some of the points which actually you may need to keep in mind. Now, coming back to data visualization, as I already mentioned, right? You go for a Tableau or you go for a Power BI. Okay. And yes, you have a lot of libraries also, like Matplotlib, ggplot, and the Seaborn. Okay. And when it comes to data analysis, probably yes, the concepts which you may need to know is a feature engineering, and you have something called as an exploratory data analysis, where you have a concept called a principal component analysis, then a data wrangling. See, there is a difference between data scraping and wrangling, but I don't want to confuse it now. For now, we will just cover the basics for now. These are all the things which you may need to keep in mind. Okay, so any questions here till now? Let us go to the chat and then see any questions here. Okay, then let me continue. Now, what about the deployment? No, make a guess. Can you make a guess? So let's say that you have built a model. you are trying to do some kind of a fine tuning to the model. All those things are fine. So how will you deploy the model? Generally, how will you deploy your code to the production in your company? Can you give me some examples? Cloud services, CI/CD. Okay. So you may use a Docker or a Kubernetes container, such kind of a thing to push the code to the production. Okay. Any other answers? Of course, yes, as part of the CI/CD only. Continuous, see, generally speaking, continuous development, continuous integration, continuous testing, continuous deployment, which we have already seen in the world of Agile when you build your CI/CD DevOps delivery pipeline. That's okay. Any other thoughts in terms of the deployment? Okay, now coming back to my experience and my knowledge, you have something called as a Flask framework. Okay, FLASK. In the world of data science, let's say that I am using an AWS or I'm using an Azure service. In the world of AWS, you can might as well create an EC2 instance using something called as a Flask model. Okay, using the Flask model, you can create it, and you can create an API service which can be readily consumed by your front end once you actually deploy it, consumed by the front end. Okay, this is the high level view. So we have talked about programming language. We have talked about little bit on the machine learning. See, in machine learning, you have three types like supervised learning, unsupervised learning, reinforcement learning. Supervised learning typically work for a labeled data. Okay, so you also need to know which one to use where. Those things we will slowly cover in the future webinar. I actually wanted to keep it a little bit light now. And then we have actually touched upon the IDE. Then you talked about the web scraping, some concepts in mathematics you still need to know, and you also need to know the analysis part, because only in analysis I am actually making sure that this particular data is actually deemed fit for me to build a model. I cannot take a raw data as it is and try to build a data science model. Okay, then the model will go for toss. And and please keep this point in the mind. Any mistake happens anywhere, you may need to repeat it all the way back, either from understanding the problem or from the data collection or from the data cleaning. So mistakes comes with a high cost. So that's why typically in a real-time project, initial 3 to 3.5 months will be going in collecting the data, cleaning the data, doing analysis on the data itself. Once you make the data deemed fit, then choosing the right algorithm to build a model is not a very tough game altogether. Okay. So maybe if you want to take a pause, you can take to think if you wanted to visualize what am I trying to tell. Okay. In the meantime, I'll just try to keep moving the ball, like keep the ball rolling. Okay. Now let us slowly get into feature engineering, because here you saw, right? Sorry. I'm just trying to. Here you have something called as an exploratory data analysis, because you are actually cleaning the data and then you are trying to do something before jumping on to building the model. Correct. So what are we trying to do there? We are trying to do something called as a feature engineering. Okay, in feature engineering, I am trying to do data cleaning. Whether you say it as a data cleaning or whether you say it as a data cleansing, the concept is trying to address missing value, trying to address null values, trying to make the data a balanced data. You try to remove unwanted things from that data set, removing the noise. And you also need to format the data, because certain type of files can only be consumed, probably a CSV or an Excel file. And also you may need to do a normalization on the data, because an unnormalized data cannot be readily applied onto an algorithm. So there is a concept called normalizing the data. And also you may need to handle something called as a categorical data. So these things I have explained in detail in my articles. When you go through these articles, you will understand it in a better manner. So I'm not going to double click on it. I'm just trying to cover a high level view. Then you do something called as a feature selection. Okay, let's say that I have created a data set, I have cleaned the data, cleansed the data. I am now trying to build a feature which can be used as a prerequisite or as a precursor activity to build the model. So here what you need to know, there is a concept called the curse of a dimensionality. Because too much of it, see, you need to take a balanced approach. Okay, if I want to put this in simple terms, too much of data will try to skew the result or try to introduce a biasing pattern. Similarly, too little data will make the model unreliable in terms of predictability. So you need to take, see, in technically there is a something called principal component analysis, which is called PCA. Using PCA, we can minimize the curse of a dimensionality, and the concept is called the dimensionality reduction. You can Google it later to get to know the nitty gritties. Okay, then how do you do this? Yes, we have some techniques for it. I'm just trying to list it out here. Four techniques. Industry says four. Maybe you have more, which I'm not aware. Okay, what are those? One is called Pearson correlation. Second is called a heat map. Third is called a extra tree. And fourth is called a classifier. Generally in the industry, using these four things, we can minimize the curse of dimensionality, we can achieve the dimensionality reduction, and you can build a better feature selection. This is the concept. Then you build the model, whatever I have mentioned it here, right? Then you try to build the model, then you deploy the model on the AWS or Azure or Flask, and then you do hyperparameter tuning later. Okay, let me pause here for a minute. You have any questions? Okay. Okay. Now what I'm going to do is, now I'm slowly shifting the gear, because now you people know the basics, right? Now I will show you real-time templates. Of course, I have removed the data. I have actually removed the data of my project. I'm just going to my own Google Drive, right? Here I have something like data science in IT, DSMP, data science mentorship program, kind of a thing. Here, what I have done, I have taken this model and just created folders: collection, preparation, cleaning, exploratory data analysis, model development, validation, monitoring, evaluation, monitoring. With this particular thing is the first step, right? Now, within this, if you click this, these are the templates what I have, right? For example, stakeholder analysis template, data science project charter. Let's say that you people are beginning a new project. Just click on this. Probably in the forthcoming webinars, we will execute a real-time code in the webinar. Okay. Now we'll show you the templates kind of a thing. This is a data science project template. Okay. Of course, based on the problem and the context, you folks need to fill the value to these variables, right? So I'm just showing you on a high level. Data science, stakeholder analysis template, so that you better understand the user persona. So here what I do, I'm just putting stakeholder name, what is his role, what is the interest level, influence level, what is the communication, what, because in a real time large projects in PayPal, Amazon, such kind of companies, this process need to be followed. You cannot just like that go and do the things, right? So come back here. We have seen the problem definition. Let's go to data collection and understanding. Okay, are we with me? You are okay, right? Because sometimes I get that doubt. The flow is going good, right? If you feel anything difficult, just let me know. I'm just trying to slowly shift the gear now, because we have already seen the theory part, right? Now I'll show the template. From the next webinar, we will execute a real-time code. Super. Okay. Now let's go here. Data collection and uh, data collection and understanding. Now, what is the data source? I want to do an assessment on the source from where I get the data, right? So let's say I created this particular template. See, many people ask me, I have challenge in creating a template. Creating a template is not a big deal if you are very good in the concept. What is a template? Template is a place where you put your thoughts in a structured manner. That is a template, right? I put the criteria. And if I don't write the description, for a beginner, it will be Greek and Latin, correct? So we put a second column called a description. The third column is the actual value from the project. By the way, what I do is I always create two templates. One is because I cannot take my project template and show it in a real-time forum on a video on YouTube. So these are the templates what I created, deliberately created for a social media purpose. Real-time project templates may be slightly more complex than this, but the essence is this. To assess the data source, these are the criteria, these are the descriptions, and actual value, I will put it over here. So on and so forth. What I have done is for every phase I have taken. For exploratory data analysis, data visualization plan, EDO report template, hypothesis template. So in exploratory data analysis, if I open it, you may have some details over there. Right? What is the data cleaning? What are the steps we have taken to see outliers? See, outlier is something which are not fitting into the boundaries. You may need to remove the outlier, but at the same time, you need to make sure are they really outliers. If not your prediction model goes for toss, right? So these are all some of the concepts you may need to know. Okay, which one to use where. Then I put something on the visualization, blah blah blah. Like this, I create something and keep it ready. I cannot use this template directly, but I have some arrows are ready in my QR. Depending upon the need of the hour, I will take something, I will customize it, I'll readily deploy it. Okay, this is something I just wanted you to people to know, because just going through an article may not give that real time feel, but the moment you see the template, you'll come to know, okay, these are the variables which is used. So from where to get the variable, what will be the value, why are we doing this in the first place? Those things you may slowly pick up. See, here I have written, see, describe the process of developing the, see, in a data science project, yes, I may have my big data team, I may have my data engineers, my data architect, all those folks will be there. But if I want to drive the show, if you want to, even for a data analytics manager or for a managerial role in data science, you still need to know these concepts. If not, you cannot have impactful conversation with them. That's what I'm trying to tell. Long story short. Okay, 1 second. I'm just thinking. Whenever I'm taking a pause, I'm just trying to organize my thoughts. Okay, I think we covered this. We covered this. Okay, now let's do one thing. Now let's go to the notepad. Okay. Okay. See. Okay. In the meantime, just to optimize our time, I wanted you people to fill this form, small Google form. Okay. Please go to this link. Just fill 4 or 5 fields in that and then send it back to me so that I will know. You basically you can fill. It could be in agile related challenges, or it could be a data science related challenges, or your career aspiration, or the challenge what you have. All those kind of things you can actually put it over there. Okay, the form looks like this. Just for your example, for your understanding. Okay, your name, mail ID, mobile number, WhatsApp number, total years of experience, feedback about this webinar, top 3 challenges in career or job, fill it and then submit it. Tomorrow I will take a look, just for your information. Okay, so that I wanted to know who are all joined the session, right, from that perspective. Okay, now let's do one thing. I'll go to the notepad parallelly. I'll go to webinar notes. There we will keep going slightly. Now I'm going to tell. Okay, now you folks have understood the concept, but what are the tools and APIs and libraries we have to implement the concept hands on, right? That will be a good exercise. Now, data analysis is also called as data pre-processing, because you are not processing it, you are making the readiness to process, so it is called pre-processing. So here only that concept of a feature engineering comes, which I already told you people. So what are the things we have? If it is a Python is a language, pandas, numpy, matplotlib, cbon, cbon, SkyPy. It is called, it is pronounced as a SkyPy, but the spelling is this. Okay. Okay. ID is what we have, Jupyter Notes, or you put it as Jupyter, Spider, and you have a PyCharm. And I also told you Visual Studio. Somewhere in the past, I told you. Okay. This is done. So I think this is good. Visualization is, as I already told you, preferably Tableau, if not Power BI. Okay. In terms of the deployment, what is that we have seen? Go for a Bitbucket or a Bitbucket, GitHub. Then you build your CI/CD pipeline, whatever it is. And most importantly, in the world of data science, we used to have something called as a Flask framework. This is not used, but still, just for your information, then you have AWS or Azure. Okay. And now coming back to machine learning and the deep learning, how to implement the concepts? Yes, we have these things which you need to know: TensorFlow, Keras, PyTorch. See, I'm just giving you a condensed view. Of course, you can get these things from n number of sources. I'm just taking from multiple sources and putting it in a simple view, the essence of the essence. Okay, yeah, if you want to know visualization, you need to know this. If you want to master deployment, you may need to know this. If you want to get into the implementation aspect of machine learning and deep learning, knowing algorithms alone may not help you. You still need to know the implementation aspect of it. For that, I am just giving some examples here. Okay, nothing more and then nothing less than that. Okay, I'm just thinking, okay, this is fine, this is fine. I think we have covered this. Okay. Okay, so these are all the basics. Okay, these are all the basics which we have seen today. Now we will get into the agile part of it, right? Now we have covered in terms of the data science. Now you know the basics. At least you know, what you don't know now. Correct? Now at least you know, these are the things I know. These are the things I know that I don't know, but still you can find it out. Now you think practically how we can use agile in this particular life cycle. Any thoughts? Go ahead and put it. If I need to do this workflow from point number 1 to 6, how I can bring agile over there? Please share your points in the chat. You might be hearing vertical slicing, horizontal slicing, different kind of slicing techniques in agile. All those things are fine, but do you think that you can really do a vertical slicing and all here? Can you take small requirement and then you vertically cut across all these things? Most likely no. So what we can do? So for that, what we'll do, I'll just show you one more article. What I have written. One second. So once you folks fill that Google form, right? So tomorrow I will be mailing you this notepad and also this particular blog, this particular notepad. That's why I'm just collecting collecting the details there. Okay. Now what I want is 1 minute. Just uh, experiential feature templates differences real time. I think I put it somewhere here. Let me check it one by one. Developing an AI model. In the meantime, you can keep putting it in the chat. Okay. How Agile can be implemented in 15 varieties of projects or engagements in IT, right? So let me go to that particular link. So when this article was written, it was written, I think, it was written on August August 25 last year, right? So here I have given, guys, if you want to how Agile can be implemented in 15 varieties of projects, all the 15 I have listed out here. So now we are not going to look into all the 15. We need to look into two things. One is artificial intelligence and machine learning projects. Other is particularly if we are already called out data science projects here. See here, sprint 1, data collection and cleaning. Sprint 2, initial exploratory data analysis. Sprint 3, model selection and prototyping. So you need to take this life cycle, juxtapose or rather superimpose this particular life cycle, cutting across the release calendar plan in terms of how are you going to get closer to the release. So if that is the logic, this is how you can slice it. See, theoretically, in the sprint 1, you are completing, but practically, if the sprint is only 2 weeks, you cannot collect data and clean it within 2 weeks. Okay. So probably sprint 1 and 2 itself need to be there for data collection cleaning. Of course, it depends upon the length of the current sprint, because a 2 week sprint is different from a 4 week. But then higher the sprint length, it is not really agile, right? Because agile demands a quick feedback mechanism. Yes, your Scrum guide says 1 month is the maximum limit, but in theory it is okay. But in reality, longer the length of the sprint, lesser will be the feedback loop, and we cannot reduce the batch size. Okay, so the flow may get interrupted. So, no, anyway, if I go for 3 weeks sprint, in the first 3 weeks I'll do only this. Then the next 3 weeks, like I will do this. So you may need to take your sprint cycle or sprint calendars, superimpose it on the data science life cycle, and then see whatever makes utmost relevance in that context. So I have given examples, okay? I'm not going to repeat the theory part. For all these things, I have given input. See, generally, I used to tell in the webinars, right? Be clear with what is the input, what is the output expected. Then you will have clarity on the process, how I can move from the input to the output. Then you put the process. Then I have given a real-time example. So go through this article. This article will actually help you to know how we can use Agile in different flavors of projects. Okay, so I will send this to you people in mail tomorrow, or my team will be sending it to you on my behalf. That's why we are telling you people to fill that Google form. Okay, I think we are closer to the time too. Let me check whether I missed out any other thing. And here, okay, okay, this particular thing I already explained. No, that particular Google Drive folders, that particular templates. Anything else? I'm just checking. Okay, let me open the forum. Let me open the forum for question and answer. I'll stop sharing. 1 minute. I think you should be able to unmute yourself. Can you try to unmute yourself or not?
Yes.
Yes, Jyoti. If you have any questions, you can go ahead and then ask it, because I can cover only this much within the limited span of 1 hour. Any questions you have, or how it like how do you feel now? You can share your thoughts. Sriram or someone, if you folks wanted to ask any question, please ask me now. I'm just putting some of my social media links. People can join these links or stay connected with me through these links. Can't unmute, huh? Okay, then just wait for a minute. Now, please check now.
Now we can unmute it right now, Balaji. Thank you.
Yes, Sriram. So you want to ask any questions or share your thoughts?
Yeah,
Please go
Balaji.
ahead.
So, first of all, this was a session I have been looking for. The reason is, this is a very broader space where people say you should be knowing AI, ML, and then people say now there is a generative AI as well, and they want to know each of these areas and to certain extent some data analytics as well. So kind of playing a role of a senior product manager or a manager, we are finding it a little difficult to see how much depth should we have to go on each of these sectors, right? So this actually gives me a kind of a condensed and consolidated overview on what I should know, what is what. Because I have been taking up a course on AI/ML a year ago. I've been to generative AI, I'm completed it. But again, still I feel like I'm not complete in terms of data science.
Okay.
And then your part on your hands-on on the Python also makes me feel like I should also have some hands-on in order to get into that role. So thank you for the session. My question is that Balaji, while we work on the data science project, let's take any software development project per se, we would be able to show incremental development as part of every sprint, right? We can show that
Correct.
this is how we develop the feature and you can see that really functioning. And here what we are doing is a development on the model. How should we as a manager should show the incrementation of the product that we build? Or what should be committed and what we should not be committing it?
So when you are actually looking into the data science itself, as I mentioned, right, the collection of the data, the data. So see, anyway, irrespective of the project, you still need to have a high level clarity on the minimum viable product and the immediate release goal, right? For
Correct.
example, R1, R2 release goal. That particular thing definitely need to be in a sync with the business imperatives. But then the point to be kept in mind is, for a given set of requirements, you are anyway funneling it through these particular life cycle phases.
Mm,
So definitely at the end of the funnel, you are going to deploy one or two features to the production or a
mm,
minimum viable kind of a model of the real-time model. Because see, here the game plan slightly changes. Correct.
mm,
It's not like a development project where I only build because here I need to build a model which is kind of an MVP validation, and I also need to do something called hyperparameter tuning,
correct.
hyperparameter optimization, so that life cycle itself will be cut into sprint 1, sprint 2, sprint 3, sprint 4, whatever
Mm,
that 1, 2, 3, 4 blocks. Okay, first block itself will take sprint 1 and 2 in
mm,
terms of understanding the business problem, understanding the requirement. So typically, see, even as you know, right, there is a difference between a greenfield versus a brownfield project. We cannot go
mm,
always tangible, deliverable to the production. So my understanding here is that first of all, the initial hypothesis validation of the MVP need to be completed in the first two sprints or the release from
mm,
from a from a one angle, then probably monitoring it and then hyperparameter tuning, all those things can be. So one release, I will still funnel out problem definition, data collection, cleaning, pre-processing, EDA, development, evaluation, deployment, monitoring, let's say for a span of 3 months, and this model will have a limited set of feature capabilities, not the
mm,
entire gamut of the equation.
mm. Got it.
Okay.
Got it.
Now, what
Yeah.
is one more thing is, now you start thinking from this angle. Now I have understood the overall flow. Why
Mm,
don't I go? Why don't I go by a role-based slicing? Means what? You have a data analyst, you have an MLOps engineer, you have a machine learning engineer, you have a data engineer. So in terms of the responsibilities, okay, yeah, this data engineer will be primarily building the data pipeline. He
correct.
will be doing an ETL kind of a job. Data analyst will be doing visualization, reporting, and some kind of a SQL query execution,
Mm,
so on and so forth. You can go even by a role based slicing, and
got
then
it.
try to, again, you be clear on the goal of the current sprint 1,
Mm,
sprint 2. Then you may need to do a role based slicing and then try to juxtapose it,
got it. Got it.
right?
Got it.
So
Uh,
maybe I don't have a very direct answer. I still
no,
need to
no.
know the ecosystem, then only I can zero in on exactly.
Sure, sure, Balaji. And one follow-up question to that is, um, whenever we do a selection of a model, that is an
Hmm.
iteration process again, correct? Certain model, people say, let's say T5, It may work well for text to text, but again, it may not work well for our given use cases. It depends upon the use case. So how much buffer time should we have to keep in evaluating the model? Because this is where I see that the time that we think that we can arrive at the evaluation of the model takes a little bit of time, because the model performance also depends upon the kind of data that we feeds in. So how should we handle this, Balaji?
Okay, see, that's a good question. Let me tell it from a pragmatic approach. See, the pragmatic approach is whenever you are doing the problem definition followed by the business statement identification, you need to be very clear on certain aspects. Okay,
Okay.
few of the aspects are: what is my stakeholder expectation in terms of the accuracy, in terms of the precision? You have
Mm.
something called as a precision recall,
Correct.
F1 score.
Different
These are
score.
all certain things which will help you see. Like in the general story, we write acceptance criteria, right? Why?
Mm.
Because definition of done will take care of a technicality, not the functional validation. Similarly, here my way of looking into it, why don't you go for a sprint zero as a planning phase,
Got it.
wherein you will define the success criteria in terms of the F1 score or in terms of the precision recall attributive value. Then you try to collect an initial data set, and then you define the assumptions in the sprint 1, sprint 2 and all. You really gear up in terms of preparation, exploration, model selection, building and all.
Mm.
So one way to answer this, okay, let me tell in this manner. If a project is taking 70% of a development effort, in the traditional world we used to give 30 to 35 percentage effort for testing, correct?
True, true. Yeah.
Similarly, generally in a project, 60 to 65 percentage will go on till the time you are building the model.
Mm.
The remaining 30 to 35 percentage is validating the model, tuning the model, optimizing the model, deploying the model, and monitoring the model. So with
Mm.
that equation, you can try to make some ballpark
Okay.
estimation, present it to the business, and get their feedback.
Awesome. Got it, Balaji. Got it.
Okay. So whenever you are having a doubt, no, you may need to think, okay, forget about it, data science. Generally, what we do in a development world in the traditional, we have 70-30 ratio. Here the ratio is 60 to 65, 30 to 35.
Mm. Okay. Got it.
Because one more thing, in the estimation, you need to clearly call out assumptions, dependencies, limitations, and constraints. Because if the model goes for toss all the way, you need to circle back depending upon the degree of variance, or the degree of error. Sometimes you may need to start it right from the beginning of data collection and problem understanding. Okay.
Got it.
Um, okay. Okay. Now,
Sure,
this
Balaji.
is one. See, now this is one part of the answer. Now, the second part is as obvious. You can still rely on your analogous models. A data science project executed for XYZ banking client
Mm.
had taken 15 months with these assumptions and validations. If I have
Mm.
that historical data, you use data science itself to, to implement a data science project.
Got it. Got it. Understood.
Okay, good. Any other questions? Okay, see, now just to paraphrase, right? Because this is the first webinar, I kept it deliberately very slow, very primary concepts. Maybe in the forthcoming, we'll just take one concept in terms of data visualization, or I will start building some kind of YouTube video only on the visualization, 3 to 4 videos, then on analysis, 3 to 4 videos. Like that, we will slowly slice the cake, then we will consume it piece by piece. Okay, that's my plan. Okay, all right. I think it's time to wrap up if there are no questions. So, anyone, okay, so before that, right, as you might be knowing, right, some of the, what to tell, okay, I'm just trying to give that because some people may not be part of my WhatsApp groups. You can actually try to join those WhatsApp groups if you are not already part of it, okay? If you're already part of it, then you leave it. This particular group, what I'm putting it in the chat is for Agile, and I will also give you the group for a data science. So just go to this group and then send a request to join. Once I approve it, you can become part of these two groups where we have our continuous learning initiatives. And these are all some of my social media links. Okay, so you can stay connected with me. I'm just putting it in the chat. Okay. So to keep it simple, if you want to interact with me further or anything like a career challenge, or you feel that you want to talk to me, you ping me on this WhatsApp number. Try to block my time, then we can get into a conversation. I generally do not take random or ad hoc calls for my own productivity. Of course, it is not that I don't want to help people, but if I'm in middle of something, I also cannot contribute my best when we are uh, interacting, right? So ping me on WhatsApp. Let's fix some time for a conversation. From there we can take it forward. Okay, any quick feedback on this from anyone? You want to share, like, right from the beginning of the webinar till now, do you feel that you gained something to explore more on the data science world? Just feel free to share it here.
Yeah, this is Kriti here, Balaji. So I think, this is very, very informative webinar for me at least, where I got
Mm.
to get a, kind of a holistic view of what all is involved in data science project. And I just wanted to ask you, like, in your future webinars, would you be, considering the fact, like, how to execute a data science project as a, as a manager or as a program manager? Like, would you be including that aspects
Yeah,
as
yeah.
well? In
Yeah,
a
sure,
webinar?
Jyoti. Yeah, so to answer your question, Jyoti, see, the plan is that, right, on some Saturdays, I will be taking webinar primarily on a Agile. Okay, because people know me, people who are regularly following me in the on the social media, they know my core competency is Agile transformation, digital transformation, delivery management, product management. Data science is something which I have a secondary kind of a capability. Yes, we have some plans in place that 1 week it will go for Agile, 1 week we will take for data science. So, and I also have some plans to slowly gear up more YouTube videos on the data science, and we'll start forming something like a data science mentorship program also. Already we have our Agile mentorship program running fine for the past 4 to 4.5 years. Now we have some plans to gear up on the data science part. But to answer your question, yes, but I was just trying to give a detailed reply to it. Okay.
Thanks a lot, Balaji. Thanks.
Sure. Okay. So a small suggestion, right, or what I felt as important to you people, I'm just sharing. Okay, as a coach or a mentor. So one of the powerful technique to continuously improve is daily you folks can do a retrospective before you go to sleep. Okay, like for example, once your day is ended, probably take a paper pen. I'm not a digital guy, so I don't prefer using electronic gadgets much. So what I do is that I take a paper pen, and then I try to run through the day. Okay, what I did from morning to night, possibly what are the potential places where I could have improved myself, or trying doing things in a different manner. See, improvement need not be always confined only to the career aspect or the professional world, right? Our personal life is much more important than career, because if you lose one job, you will get umpteen jobs in the market. Personal life, health, finance, all those aspects are also very important, like in terms of relationship building also. So I tend to do a retrospective, some 5 minutes retrospective, and I just close the diary and then I go to sleep. At the weekend, I run through the entire week, the previous week from Sunday to Saturday. Okay, what I did, possibly where I wasted my time, possibly what are the areas where possibly I could have improved in a much more better manner. So these kind of incremental improvements over a period of time will start building monumental possibilities. So you cannot expect to become a kind of a superhero overnight, right? In terms of competency building and the capability. So sometimes I generally suggest in my mentorship program also, you folks daily do a kind of retrospective, and then try to revisit the diary and then see what thing you could have done in a better manner. I think this one powerful thing will give a transformation. Because when we say, we are not saying agile information, we are saying agile transformation, right? Information is different from transformation, right? So you do this retrospective, you believe me, over a period of 4 to 6 months, yourself will feel the change. Okay. So that's a small tips I wanted to tell to you people in the best interest of you. Okay. All right, then. Thank you. I'm just ending the recording here.